We are given a triangle ABC and D is the midpoint of side BC. Then we need to prove that AB square plus AC square equal to 2AD square plus BD square. Let's do it using vectors. For that purpose, we draw a triangle ABC and we have a triangle ABC. D is the middle point of BC, so BD equal to DC. As we want to prove using vectors, let's introduce vectors. So we have AC, that is a vector from A to C. Then we have AB, and then we have AD. Now we can write AC as we have several triangles, so let's consider triangle ADC. In triangle ADC, comma, AC equal to, that's moving from A to C, that is same as moving from A to D, then D to C. So AC equal to AD plus DC. Now if we take dot product with itself, so let's write AC equal to AD plus DC once again. AC equal to AD plus DC. AD plus DC. So let's take dot product of those two quantities. So we have AC dot AC, that is, or let's write AC dot AC equal to AD plus DC dot AD plus DC. AD plus DC dot AD plus DC. Now AC dot AC is nothing but AC square, because angle between AC is 0 degree. AC dot AC is magnitude of AC. So let's just recall that A dot A equal to A times A into cos 0 degree, because angle between A and A is 0 degree. With that we have A dot A equal to A square, because cos 0 degree is 1. And with that we have AC dot AC equal to AC square. Right hand side we apply distributive law and we have AD dot AD plus DC. Again we apply distributive law plus DC dot AD plus DC. So left hand side is simply AC square AD dot AD. If we apply distributive law once again, we have AD dot AD. Using this identity A dot A is equal to A square, we have AD dot AD equal to AD square. AD dot DC, let us copy as it is. DC dot AD also let's copy as it is. DC dot AD. DC dot DC is DC square. Now let's look at the identity that we want to prove. We have in the left hand side AC square and then AB square. AC square we got it equal to AC square, we got it equal to, by applying AD plus DC, we have AC square equal to AD square plus AD dot DC plus A. DC dot AD is same as AD dot DC. So we can simply write it as AD square plus 2 AD dot DC plus DC square. Similarly, in triangle ABD, in triangle ABD, in triangle ABD, AD equal to, moving from A to D, by triangular, moving from A to D is same as A to B, then B to D. AD equal to AB plus BD. AD equal to, that's moving from A to D. Moving from A to D is same as move from A to B, then B to D. AD equal to AB plus BD. And so AB can be written as, we can rearrange it and write it as AB is AD minus BD. And then we can repeat the previous process to have AB square equal to AB square equal to AD square minus 2AD dot BD plus BD square. So we write this one is equation 1 and this one is equation 2. Adding equation 1 and 2, we have, if we add equation 1 and 2, AC square plus AB square. That's your left hand side. If we add equation 1 and 2, AC square plus AB square, that is your left hand side of what we need to prove. AB square plus AC square equal to, if we add AD square and AD square, then you will get 2AD square. Plus 2AD dot DC, 2AD dot DC minus 2AD dot BD plus DC square plus BD square. But remember, DC and BD, they are of same length. That's what we are given to us. DC and BD are of same length. So DC square plus BD square can simply be written as plus BD square. And we can have another BD square because DC and BD, they are of same length. Now we got 2AD square, that's what we have in right hand side. 2BD square, that's also there in right hand side. Something extra, these are not there in the right hand side. But observe that we can take 2AD common. So we can write it as plus 2AD DC minus BD. 2AD dot DC minus BD. Are DC and BD equal? DC, remember we are moving from D to C, and as we move from D to C, the length DC remains same. And we are moving from B to D, the length BD is same as length DC, and direction it will also remain same. So we can say DC equal to BD because their magnitude is same and also their direction. If their magnitude and direction both are same, they are equal. So DC minus BD is 0. So we have simply equal to, right hand side equal to 2 times, so we can take 2 common, AD square plus BD square. So we have AC square plus AB square equal to this, and so AC square plus AB square equal to 2 times AD square plus DC square, and we have proved.